All right, so let's try one more problem. So here's our number 7. Carla decides to turn her attention to rectangles, knowing that a rectangle is defined as a quadrilateral with 4 right angles, right? So again, there's my definition. After some exploration, she writes a conjecture that all rectangles are also parallelograms, right? Which basically means that this side has to be parallel to that side, and that side has to be parallel to that side. Okay. So where should we start? Right? We should start that we want to look at angles. Okay. So in order to prove that these two lines are going to be congruent, we have to talk about these two angles. In order to prove that these two lines are congruent, we're going to talk about maybe these two angles or these two angles. Okay, so let's take what we were doing in the first one. And so I'm going to say that the measurement of angle Q is equal to 90 degrees. And the reason why we have that is technically it was given to us, so we can either write given or we can say definition of a rectangle. I'm going to write definition of a rectangle because that's what we were given. And then let's talk about T. So we'll say the measurement of angle T is also 90 degrees. And again, definition of a rectangle. If I say that Q and T, right, QT, are 90 degrees and they're equal to each other, if I come back to this past problem, right, when we were looking at MN and PQ, right, we said that those were given to each other, addition properties, so we said that the same sides are parallel. We can sometimes cut out the middleman. This would be the middleman right here. So we can kind of just jump down to this information. Okay, so I get to say from here and here, I'm going to say that QR, so QR right here, is going to be parallel to TS, right? And the reason why we get to say that is that our same side interior angles are supplementary. Therefore, we have parallel lines. So therefore, parallel lines. Again, we don't need this second part as long as we have this. Okay, so I got one set of parallel lines. So let me put those parallel lines in red. So now, right, I've already used one of those. So now I want to prove that this line is going to be congruent to, or sorry, parallel to that line. Okay, so we've already done, so now we've already done Q and T. So let's use Q and R. So these are consecutive angles as well. So this time we've already have Q. So I'm just going to say, actually, I'm going to rewrite this. I'm going to say measurement of angle Q is equal to, actually, you know what I'm going to do? I'm going to do it over here. So that way I can write it. So I'm going to say measurement of angle R, let's do it this way, is equal to 90 degrees. And again, Y, def of a rectangle. Okay, and this guy plus this guy, that way I don't have to rewrite it. I can now say that QT is parallel to RS. Right, and again, same side interiors are supplementary. Okay, if they're supplementary, right, therefore our lines are parallel. Right, therefore we have two sets of parallel sides. Right, so then my final answer will be that this plus this means that QRST is what? A parallelogram. Why do I get to say that? It's because it's the definition of a parallelogram. All right, we covered a lot in this video, or in these parts of our videos. All right, I know it's a lot to handle. So here's what I was talking about as the methods of meetings box, right? So these are our definitions. So we don't need to create these definitions. Okay, So anytime you want to say that something is a trapezoid, here's our definition, at least one pair of parallel sides. If you want to say that it's a parallelogram, again, two pairs of parallel sides. If something is a rectangle, it's a quadrilateral with right angles. So again, it's very important to have these definitions out. You will also find that you will have some a theorem toolkit. So these are basically what we've just proven in all of our problems. Okay. So our first one that we proved is that opposite sides of a parallelogram are congruent, and we proved that in our second problem. So not only are parallelogram sides parallel to each other, but now we know that opposite sides are congruent to each other. Okay, so we can use this now. It is a theorem. We've proven it true. We know that a kite has at least one pair of opposite angles that are congruent, right? So again, this angle will be congruent to that angle. This is not congruent to that. Okay, not necessarily. We also proved that a diagonal, right, will bisect. So a diagonal of a kite that does not go through the congruent angles is an angle bisector, right? So we didn't necessarily write a flow chart for that, but that was part of one of the questions. Again, you'll find this all on the website, so we don't have to copy it down. Diagonal bisects the other one. So again, we saw that this was one of the ones that we did not prove, that the diagonals of the kite are perpendicular. And then last but not least, right, the quadrilateral has two right angles, making it a trapezoid for sure. This is also specifically known as a right trap. Okay, and then the opposite sides of a rectangle are parallel. And then if a quadrilateral is a rectangle, then it is also a parallelogram, right? The opposite is not true. If a quadrilateral is a parallelogram, it doesn't mean it's a rectangle. Rectangle means that you have to have those 90-degree angles, right? All of these theorems are going to be helpful as we start to create more of these complex flowcharts that you guys are going to be doing in this chapter. So please make sure that you do either print these out or write them down in your notes as well, and make sure that you have also used our definitions of a quadrilateral either in your notes or printed out as well. Okay, any questions or concerns, feel free to always email us.